What is a triple point?
The triple point is the temperature at which a substance can exist in equilibrium in all three of its states: gas, liquid, and solid. For pure water, the triple point at an air pressure of 4.58 mm of mercury is 32.018 degrees Fahrenheit, 0.01 degrees Celsius. The term triple point, however, can also refer to the spot where an occluded front meets a warm front.
What is an air pocket?
Air pockets are caused by turbulent air. Many people who have ridden in airplanes are familiar with them, as they cause that bouncing sensation as you hit an updraft, followed abruptly by a downdraft, in quick succession.
What is a low-high temperature and a high-low temperature?
When meteorologists look at daily temperature, there is always a low and a high temperature for each day. If the high temperature is the coldest high temperature for that day or for the month on record, you have a new record, a new low high. Conversely, if the low temperature for a day is quite warm and breaks records, that's a new high low.
What would happen if a large comet or asteroid impact occurred?
If a large extraterrestrial body, such as a comet or asteroid, with a diameter of 6 miles, 10 kilometers, or more struck anywhere on our planet, land, or sea, the impact would be felt worldwide. The initial impact would vaporize parts of the Earth's crust, as well as the oceans, and send shockwaves out to every corner of the globe. Debris would be shot out into the upper atmosphere, and the heat generated from the collision with the atmosphere and crust would turn the sky red and set the world's forests aflame. After the initial collision, debris would rain down everywhere, destroying even those buildings, wildlife, and people who were far from the impact. Virtually all living things inhabiting the surface would be killed, and even sea creatures would die as the temperatures of the oceans reached the boiling point. Long after the impact, the atmosphere would be coated in a layer of ash that would circle the Earth for months or even years, plunging the planet into a nuclear winter after the initial fireball. About the only things that might survive such as is believed to have happened 65 million years ago. After the last such event would be creatures that could burrow underground or hide deep inside caves.
How is rainfall measured?
Agencies like the National Weather Service use very accurate devices that measure rainfall to the nearest 1/100th of an inch. The devices, known as rain gauges or tipping bucket gauges, Collect rainwater at a point unaffected by local buildings or trees that may interfere with the rain.
What is the sunburn index?
The sunburn index, which is also known as the UV index, was developed by the National Weather Service and the Environmental Protection Agency as a way to provide people with information as to the varying risks of sunburn on particular days. Ranging in scale from 0 to 10, 10 being the riskiest, the index is calculated based on several factors: day of the year, latitude, elevation, cloud cover, and ozone levels. People with fair skin should be the most cognizant of the UV index when venturing outside. Though people with tan or dark complexions should not ignore it either. The table below explains the index in more detail.
Are there any circumstances where air pollution could be beneficial?
Yes. In fact, dust storms and volcanic ash can be a means for nature to distribute soils across the surface of the planet to regions that might not otherwise get certain nutrients. For instance, the Amazon rainforest may be famous for its verdant plant life. But in actuality, the soil beneath the dense canopies is of very poor quality. Dust blown across the ocean from Africa to South America may help fertilize the rainforests. Not only that, but such storms bring nutrients to plankton in the ocean, which form the basis for aquatic food chains.
How many people will find themselves in flooded coastal regions should global warming melt the ice caps?
Worldwide, over 150 million people would find themselves underwater by the year 2070 should scenarios about global warming play out. This includes 130 important port cities, such as New York City, Tokyo, Hong Kong, Mumbai, and Bangkok. A 2007 estimate said that this would have an economic impact of $35 trillion, an amount no nation is currently equipped to surmount. Not only would such a flood destroy coastal cities, but mass migrations would occur, causing political and social unrest that many believe would inevitably lead to military conflicts, famines, and disease.
What is heat exhaustion?
When the temperature is too high and people do not drink enough fluids, exert themselves too much, or spend too much time in the direct sunlight, heat exhaustion can result. Symptoms can include weakness, cold and clammy skin, paleness, fainting, irregular heartbeat, and vomiting. In extreme cases, heat exhaustion has been known to kill. There have been a number of cases where people exercising at a sports Practice or conducting drills in the military have collapsed and died. Seniors and people who are already ill are particularly susceptible to heat exhaustion.
Where is lightning most likely to occur?
Lightning tends to strike more often over land masses than over oceans. And it is more frequently seen in the tropics, where 2/3 of the electrical storms happen.
Do ocean currents affect coastal weather?
Yes, ocean currents have the effect of moderating climates along coastal regions. Ocean waters tend to stabilize temperatures, which is why living on the coast of Southern California, for example, is a much more pleasant climatic experience than living farther inland, where it is much drier and warmer.
How far does the solar wind travel?
The sun's corona extends millions of miles beyond the sun's surface. The plasma of the solar wind, however, extends billions of miles farther, well beyond the orbit of Pluto. Beyond there, the plasma density continues to drop. There is a limit, called the heliopause, where the influence of the solar wind dwindles to just about nothing. The region inside the heliopause, which is thought to be some 8 to 14 billion miles, 13 to 22 billion kilometers, from the Sun, is called the heliosphere.
What are black smokers?
Black smokers are actually deep ocean hydrothermal, hot water, vents, named after the dark, soot-like material ejected from chimney formations on the ocean floor. The material is actually superheated water, around 662 degrees Fahrenheit 350 degrees Celsius, with very high concentrations of dissolved minerals, mostly sulfur-bearing minerals or sulfides from lava on a mid-ocean ridge volcano. As the hot water meets the cold ocean waters, the minerals precipitate out, settling out around the surrounding rock. Over time, the hollowed-out chimneys grow taller as more minerals precipitate out. Black smokers tend to occur in volcanic vent fields that are typically tens of yards across, with fields ranging from pool table size 43 square feet 4 square meters, to tennis court size 8,288 square feet 770 square meters. For example, vent fields are found on the Juan de Fuca Ridge, a mid-ocean ridge in the Pacific Ocean. Many vents have been discovered since the first site was found in 1977 near the Galapagos Islands. In the small research submersible Alvin, and there are probably many more. But scientists have only explored a small portion of the Earth's mid-ocean ridges.
Do people frequently die from lightning strokes?
Depending on sources. Anywhere from 5 to 30% of people who are hit by lightning die from their injuries. The danger is not so much from burns but rather from the electrical energy stopping a person's heart. This is why CPR usually is necessary when someone is struck unconscious by lightning. More often, people who have been thus injured will be in severe pain and will be screaming as a result. While they of course will need medical attention, their prognosis for survival is much better than that of the unconscious person.
How is snowfall measured?
Snowfall is measured in a very practical and low-tech way, with a ruler. To get a good average indication of snowfall in a selected area, the National Weather Service takes measurements from several locations, instead of just one, and then averages them out. In places where there is often heavy amounts of snow, tall poles are erected that can measure the white stuff when it accumulates up to several feet, or even meters, deep. Snowfall can also be measured using a heated rain gauge, which melts the snow into water, then converts it back to estimated snow levels by using the formula that 1 inch of rain water roughly equals 10 inches of snow. However, in North America, this method is not really used because it is not very accurate. There is also the snow pillow method for measuring snow, which uses a scale to measure the weight of the snowfall. In snowier climates, a tool called a snowboard, which is not the same as the snowboards used for wintertime fun, is used. A snowboard is a 2-foot wide by 2-foot high piece of plywood that is painted white and put in a location where snow is not likely to drift. The purpose of the white paint is to minimize the melting effects of solar radiation. Snow depth measurements are then taken with a ruler every 6 hours. The 6-hour rule is hard and fast. This was made clear in 1997, when an observer for the National Weather Service recorded a snowfall of 77 inches, 196 centimeters, in Montague, New York, within a 24-hour period. This would have been a world record, but it was disallowed when investigators learned that the observer recorded measurements every 4 hours instead of every 6.
How fast does rain fall?
The speed of rainfall varies with drop size, wind speed, and the size of the raindrops. A typical raindrop in still air falls about 7 miles, 11 kilometers, per hour. Large raindrops can reach speeds of 16 to 20 miles, 26 to 32 kilometers, per hour. While the tiniest drops are slower than a mile, 1.6 kilometers, per hour as they drift to Earth. Thus, the larger drops can usually splash onto the ground about 3 minutes after being generated in a rain cloud that is about 5,000 feet, 1,500 meters, above the surface.
How can I obtain a flood map of my community?
The best way to see a flood insurance rate map, firm, for your area would be to contact your local government, their planning or emergency management agency should have the firm maps available. Purchasing them from FEMA is not recommended because the maps change often and are best interpreted by a planning or emergency expert.
Is it ever too cold to snow?
No matter how cold the air gets, it still contains some moisture. And this can fall out of the air in the form of very small snow crystals. Very cold air is associated with no snow because it is usually very dry and these invasions of air from northerly latitudes are associated with clearing conditions behind cold fronts. Heavy snowfalls are associated with relatively mild air in advance of a warm front or on the backside of a strong low-pressure system. The fact that snow piles up, year after year, in Arctic regions illustrates that it is never too cold to snow.
What should you do if you are stranded in your car during a blizzard?
If you are far from any buildings or people who might help, rather than getting out of your car and wandering off, possibly getting lost or freezing to death, it is always a better idea to remain in your vehicle. Hopefully, you will have a charged cell phone handy, but if not, it is still better to remain in the car. After checking to make sure that the car's exhaust pipe is not blocked by any snow or ice. Being wary of carbon monoxide poisoning, keep the car running for as long as possible to stay warm. Also, turn on your hazard lights, which may attract help, such as a police officer, while also warning snow plows not to come too close. During the winter months, it is a good idea to keep blankets, food, a spare tire, and a first aid kit in your car. Never drink alcohol to try and stay warm, but a thermos containing a hot beverage or soup would prove handy.
What is a neutrino?
A neutrino is a tiny subatomic particle that is far smaller than an atomic nucleus. It has no electrical charge and a tiny mass. Electrons are many thousands of times more massive than neutrinos. And protons and neutrons are many millions of times more massive. Neutrinos are so tiny and ghostly that they almost always pass through any substance in the universe without any interference or reaction.
How much carbon dioxide is being produced by cars and industrial emissions in the United States?
A 2004 study from the Environmental Protection Agency noted that total emissions from 1990 to 2004 have increased by 15.8%. While this is not great, when compared to an increase in the U.S. gross domestic product of 51% over the same period, it is a somewhat controlled increase.
What is an ion?
Ions are atoms or molecules with a positive or negative charge due to differences in the number of protons. Positively charged particles in an atom's nucleus, and electrons, negatively charges particles that orbit the nucleus. Meteorologists are interested in ions, especially with regard to the ionosphere, because they are highly reactive with other elements and chemicals in the atmosphere.
Who created the first artificial snowflake?
Japanese physicist Yukichiro Nikkei, 1900 to 1962, created the first artificial snowflakes. At Hokkaido University in 1936. Nikkei, who was inspired by the photographs of Wilson A. Bentley, 1865 to 1931, also devised a rather poetic snowflake classification system, which he described in his 1954 book, Snow Crystals, Natural and Artificial.
What is a Chinook?
A Chinook, sometimes called a snow eater because it melts snows, is a wind that is generally warm and originates from the eastern slope of the Rocky Mountains. It often moves from the southwest in a downslope manner, causing a noticeable rise in temperature that helps to warm the plains just east of the Rocky Mountains.
How far is it possible to see through the atmosphere?
On a clear day that is free of haze and pollution, it is possible for people to see objects as far as 200 miles, 322 kilometers, away. At night, bright lights can be visible from as far away as 500 miles, about 800 kilometers.
What causes a tornado?
Scientists still do not fully understand how a tornado forms and why. The general theory is that tornadoes form from cloud systems that are slowly spinning, usually in supercell storms, but weaker systems can produce them as well. The current belief is that a mesocyclone within a storm system is surrounded by pronounced variations in air temperature and downdraft. However, tornadoes have been known to form in cloud systems where strong winds and variations in temperature do not exist. Once a funnel begins to form, however, it can gain speed and strength in much the same way as ice skaters gain rotation speed as they pull their arms close to their bodies.
What are some other unusual events that saw a sudden increase in temperature in the United States?
Extreme shifts in weather patterns, such as when a strong warm or cold front moves through a region, have been known to cause rapid changes in temperature of 40 to 80 degrees Fahrenheit. Sometimes in periods lasting less than an hour. One of the most stunning examples occurred in Great Falls, Montana. On January 12, 1980, when Chinook winds carried warm air into the city. A hydrologist for the National Weather Service reported that over a period of just 7 minutes the temperature in Great Falls rose from -32 degrees Fahrenheit -35.5 degrees Celsius to 15 degrees Fahrenheit -9.4 degrees Celsius. A change of 47 degrees Fahrenheit, or 22 degrees Celsius, which was a record, at least in the United States. Previously, Montana held the record when on December 1, 1896, the temperature changed by 36 degrees Fahrenheit in 7 minutes in the town of Kip. It rose a total of 80 degrees Fahrenheit, 37.7 degrees Celsius, that same day over just a few hours. While not occurring over such an impressively short period of time, there have been many other incidents in the United States where abrupt temperature changes have happened within a relatively short time frame. Below are some other remarkable temperature changes.
How do meteorologists predict weather using changes in air pressure?
Meteorologists can forecast many details about the weather based on barometric readings. Generally, changes in air pressure indicate the following. Decreasing pressure foretells rainy, windy, stormy weather. Small, quick drops in pressure are good indicators that short periods of wind and rain will follow. Slow, moderate drops in pressure indicate a low-pressure system is in the area, but this will not likely cause severe weather. Slowly decreasing pressure over a longer period of time foreshadows poor weather that will last for some time. Slowly decreasing pressure that was preceded by high pressure means that poor weather will be particularly bad. Increasing pressure is an indication of dry, colder weather. Slow, large rises in pressure mean that good weather is approaching and will likely last a long time. Rapidly rising pressure when the pressure is already low is a good indicator of upcoming fair weather. Rapidly decreasing pressure is a good prediction that a storm will hit within 6 hours.
Why is the sun essential for weather?
Our sun is the source of almost all of the energy that creates weather on the planet, plate tectonics. The heat within the Earth, tidal effects, radioactive elements, and the effects of gravity from Jupiter and Saturn provides the rest. The majority of the energy, 99.98%, is from the sun, however. Although the amount of light, heat, and other energy from the sun that hits the Earth is equal to only 5 × 10⁻⁻⁻ of its total output. This is still the equivalent of burning 700 billion tons of coal every day. It has also been calculated that the energy reaching Earth's upper atmosphere is equal to 5 million horsepower per square mile. That's enough to rev up the engines of 7,400 Indianapolis 500 race cars. Planet-wide, that would be about 14.5 billion race cars being powered up daily by the sun. If the sun's energy on the planet's surface was constant, it would not affect weather. This is not the case. Because our planet spins, giving us day and night, and tilts, giving us the seasons, the energy is not distributed evenly. Also, clouds and variations in the upper atmosphere affect solar energy levels. The result is that Earth is covered with areas of colder and warmer air, causing air masses to move, which are, in turn, diverted this way and that by variations in geography and the Coriolis effect. This is what gives us the weather.
How can a solar eclipse influence the weather?
During a solar eclipse, the moon casts a dark shadow, called the umbra, onto the Earth's surface, as well as a lighter shadow called the penumbra. The umbra can be about 170 miles, 274 kilometers, in diameter, darkening the sky and cooling the air just as if the sun were setting. Temperatures have been known to drop many degrees during a solar eclipse, especially during a total eclipse. For example, in Baja, California, the temperature dropped from 90 degrees Fahrenheit to 74 degrees Fahrenheit. 32 degrees Celsius to 23 degrees Celsius, on July 11, 1991, because of an eclipse. The effect, however, is short-lived, as total eclipses rarely last more than 7 minutes. And specific locations on the planet only experience them once every 4 centuries or so.
What is a rain shadow?
When the moisture in the air is squeezed out by orographic precipitation, there's not much left for the other side of the mountains. The dry side of the mountains experiences a rain shadow effect.
How did Earth's atmosphere form?
Some of Earth's atmosphere was probably gas captured from the solar nebula 4.5 billion years ago, when our planet was forming. It is thought that most of Earth's atmosphere was trapped beneath Earth's surface, escaping through volcanic eruptions and other crustal cracks and fissures. Water vapor was the most plentiful gas to spew out, and it condensed to form the oceans, lakes, and other surface water. Carbon dioxide was probably the next most plentiful gas, and much of it dissolved in the water or combined chemically with rocks on the surface. Nitrogen came out in smaller amounts, but did not undergo significant condensation or chemical reactions. This is why scientists think it is the most abundant gas in our atmosphere. The high concentration of oxygen in our atmosphere is very unusual for planets. Because oxygen is highly reactive and combines easily with other elements. In order to maintain oxygen in gaseous form, it must constantly be replenished.
When did modern weather forecasting begin?
On May 14, 1692, a weekly newspaper, a collection for the improvement of husbandry and trade, gave a 7-day table with pressure and wind readings for the comparable dates of the previous year. Readers were expected to make up their own forecasts from the data. Other journals soon followed with their own weather features. In 1771, a new journal called the Monthly Weather Paper was completely devoted to weather prediction. In 1861, the British Meteorological Office began issuing daily weather forecasts. The first broadcast of weather forecasts was done by the University of Wisconsin Station 9XM at Madison, Wisconsin, on January 3, 1921.
How is hail formed?
Hail is precipitation consisting of balls of ice. Hailstones usually are made of concentric, or onion-like layers of ice alternating with partially melted and refrozen snow, structured around a tiny central core. It is formed in cumulonimbus or thunderclouds when freezing water and ice cling to small particles in the air, such as dust. The winds in the clouds blow the particles through zones of different temperatures, causing them to accumulate additional layers of ice and melting snow and to increase in size.
What is the Bruckner cycle?
The Bruckner cycle refers to the idea that periods of unusually wet years are then followed by drier than normal years in a cycle that alternates about every 35 years. Though it may fluctuate by as little as 20 and as much as 50 years. It is named after German geographer and meteorologist Eduard Bruckner, 1862 to 1927. The cycle is also related to colder and warmer years. Bruckner, who was also very interested in climate change and glacier advancement and retreats. Based his theory on his research into glaciers and tree rings. Because there is so much variation in these cycles, though, climatologists have become much more interested in both the shorter-term and longer-term changes in climate.
How do ocean currents affect weather?
The world's oceans cover about 70% of our planet's surface. Thus, ocean water also absorbs more heat from the sun than the land does. In addition to this, water absorbs and emits heat energy more slowly than land does. Warm water, therefore, remains warm longer, and cold water remains cold longer. As the world's ocean waters circulate through the action of currents, this warm or cold water can be transported long distances before it changes temperature. This is an important way that Earth distributes its heat energy. Warm waters in the tropical Atlantic Ocean are carried north as far as England and Scandinavia. For instance, while warm waters in the Indian Ocean circulate down toward Australia and South Africa. Land barriers, such as that formed by Central America, are vital for diverting currents in various directions. It's because of this that currents from Western Africa move toward the Caribbean, and are then deflected north. Without Central America, Great Britain would be as frigidly cold as the remote wastes of northern Siberia.
What two volcanic eruptions had the biggest impacts on the climate in the 20th century?
The eruption of El Chichon in southern Mexico, which lasted from March 29 through April 4, 1982, and the June 15, 1991, eruption of Mt. Pinatubo in the Philippines caused significant disruptions to the planet's climate. El Chichon shot about 7.75 million tons, over 7 billion kilograms, of sulfur dioxide into the atmosphere, as well as some 24.25 million tons, 22 billion kilograms, of other dust and particles. Coincidentally, there was a strong El Niño building at the same time. While the El Niño effect worked to warm ocean waters, the El Chichon eruption was cooling the atmosphere. And the result was that the two effectively cancelled each other out. That summer, when temperatures should have increased because of El Niño, the average temperatures were actually fairly normal. During the winter of 1982 to 1983, though, temperatures in Europe, Siberia, and North America were higher than normal. And temperatures in the Middle East, China, Greenland, and Alaska were cooler. This was because the gases from El Chichon had caused an Arctic oscillation in the stratosphere, changing air current patterns. When Mount Pinatubo erupted, it sent 20 million tons of sulfur dioxide into the sky. And estimates are that this resulted in an average worldwide temperature drop of 1.7 degrees Fahrenheit (0.8 degrees Celsius) in 1992. The effects continued through 1993. As the haze produced by the extra sulfur dioxide in the atmosphere reflected the sun's rays.
What is forensic meteorology?
With the popularity of the CSI television series, there has been a meteoric rise in students enrolling in forensic science courses. Forensics draws on a wide variety of sciences in order to solve criminal cases. For instance, there was one episode of CSI in which a character used his knowledge of astronomy to locate a murder scene. Meteorological principles can also be used in forensics, which is frequently applied to criminal or insurance investigations. Meteorologists have been called to testify in court, serve as consultants, or perform research for government agencies, law firms, and private businesses. Using data from satellites, radar, and other sources, a meteorologist could, for example, testify as to the possibility of a building fire being caused by lightning, or whether or not wind conditions could be responsible for an airplane crashing shortly after takeoff, or whether hazy conditions leading to a car accident were the result of nature or a nearby factory. Qualification as a certified consulting meteorologist is typically required to work as a forensic meteorologist.
What are some disturbing statistics regarding air pollution in Egypt?
The World Health Organization estimated that breathing the air in Cairo, Egypt, is the toxic equivalent of smoking 20 cigarettes every day. Damage to the Egyptian economy as a result of pollution is also troubling, with the World Bank noting in 2002 that 5% of the country's gross domestic product, or about $2.42 billion US, are lost annually due to damages attributed to pollution.
Does drinking alcohol truly warm up a person's body?
While drinking a shot of bourbon or other alcoholic drink on a winter's day might provide a sensation of being warmed up, in actuality alcohol makes a person's body more vulnerable to the cold. When you drink booze, what happens is that the alcohol causes blood vessels to constrict. This forces more blood to the surface of the skin, which stimulates nerves in the body and makes the drinker feel warmer. The actual effect, however, is that increased blood to the surface of the body causes one to lose more heat, lowering body temperature and making him or her more susceptible to frostbite. Add to this the fact that alcohol impairs one's judgment, and the idea of drinking on the ski slopes proves to be a very bad one indeed.
What are waterspouts?
Often associated with tropical cyclones, waterspouts are tornadoes that can form over a body of water. Instead of sucking up dust and debris, the funnel is visible because of the water it carries. While they tend to be weaker than tornadoes, they can still be lethal and have been known to destroy small boats and cause damage to larger vessels. The most common place to find waterspouts in the United States is off the coast of southern Florida.
What is hydrology?
Hydrology is the scientific study of Earth's water supplies, how they are distributed, and how they move and change. Hydrologists are people concerned with water resources, and their work has applications ranging from civil engineering and city planning to environmentalism and conservation.
How is the troposphere defined?
The troposphere is considered as the layer closest to Earth and is also the region where temperatures reliably decrease with altitude. The troposphere is thickest at the Earth's equator, reaching heights of about 11 miles. 17 to 18 kilometers, and this is, therefore, also where you will find the coldest tropospheric temperatures. It might seem rather ironic that, right above the world's steamiest tropical forests, temperatures can be as low as -110 degrees Fahrenheit, -79 degrees Celsius.
What are equinoxes and when do they happen?
An equinox is a time of the year when, in the course of Earth's orbit, our planet is at a location where the equatorial plane and the ecliptic plane intersect. In other words, the tilt of Earth's axis is pointed perpendicular to the line between Earth and the Sun at an equinox. Earth's poles are tilted neither toward nor away from the Sun, but tilted off to the side. On the day of an equinox, there are as many minutes of daylight as there are of night, hence the term equinox, meaning equal darkness. In the northern hemisphere, the vernal, spring, equinox occurs around March 21st of each year, and the autumnal, fall, equinox occurs around September 21st.
What is smog?
The word smog is a combination of two other words, smoke and fog. Harold DeVos, a British physician who was concerned about air quality, is credited with coming up with coining the term in 1911. However, what we refer to as smog has nothing to do with either fog or smoke, usually. Smog is simply another name for air pollution. Scientists refer to it, more precisely, as photochemical smog because it is the result of chemical reactions in the presence of sunlight. The brownish haze associated with smog is the result of nitrogen dioxide in the air. But smog also includes a soup of nitrogen oxides, hydrocarbons, aldehydes, ozone, peroxyethanoyl nitrates, PANs, and suspended particulate matter. Yuck.
How fast do hurricanes travel?
A typical hurricane will travel across the ocean at a speed of about 250 miles. 400 kilometers per day, or about 10 to 15 miles, 16 to 24 kilometers per hour. They have been known, though, to advance at speeds as fast as 60 miles. 96.5 kilometers per hour, which was the case during the New England hurricane of 1938.
What is a diurnal temperature range?
As one might guess from the term, diurnal temperature range means the variation between the lowest and highest temperatures during a given day at a certain location. This can vary widely, depending on the season and place. For example, the climate on the Front Range of the Rocky Mountains in North America has been known to change by as much as 100 degrees within a 24-hour period, while in the tropics temperatures tend to remain more stable, changing by, perhaps, 10 degrees or so within a specific day.
Why are radio transmissions weaker at night than during the day?
At night, of course, much less light is entering the atmosphere, which means that less ionization is occurring and fewer electrons are available for radio waves to bounce off of. The result is that radio transmissions are weaker.
What causes deep ocean currents to flow around the world?
The deep ocean currents are driven by thermohaline circulation, which is movement caused by differences in the temperature and salinity content of the water. Because cold, salt-laden water is heavier than warm water, it sinks to the bottom of oceans. To replace it, warmer water fills in, and as it subsequently cools, the rotation is repeated. This constant movement of water has often been referred to as a giant global conveyor belt or pump that slowly circulates water all over the world's oceans. For example, the warm Gulf Stream current is heated by the sun, starting in the Caribbean. It then flows north along the east coast of North America, mostly along the United States coastline, until it reaches subpolar waters in the North Atlantic. Between Greenland and Norway, the cold Arctic winds cool the salt-laden water almost to the freezing point. Huge amounts of the now cold, Heavy salt water sink at this point to depths of around 3 to 4 miles. 5 to 6.5 kilometers, and begin the next phase of the journey. Traveling southwards through the western Atlantic basin to the Antarctic circumpolar current. And then into the Indian and Pacific Oceans. This trip takes many years. Off the coasts of Peru and California. For instance, upwellings often consist of ocean waters that sank to the depth centuries before.
Which ocean currents are the slowest?
The slowest currents are found deep in the world's oceans. These sluggish, cold waters take up to about 1,000 years to circulate around the entire globe.
What key event brought the issue of acid rain to prominence?
During the 1960s, fish began to die in Scandinavian lakes at an alarming rate. When investigated, it was found that the lake water had become so acidic as to be unlivable for many species. The source of the acid was European industrial emissions creating acid rain and snow. Further research found that lakes in the United States, Canada, and other nations were suffering the same fate.
Does the Coriolis effect make the water in my toilet, sink, and bathtub swirl clockwise?
No, the Coriolis effect has very little effect on such small bodies of water. The flow down the drain is mostly a function of the shape of the container. Interestingly, if your body were completely symmetrical, and no one's is, and neither leg were longer and you were walking on perfectly flat land, then you might start veering due to the Coriolis effect.
How does the Gulf Stream affect the weather of the British Isles and Scandinavia?
The Gulf Stream currents move warm water in the Atlantic Ocean from the Caribbean Sea northeast to northern Europe and the British Isles. The current flows in this manner because currents heading west from the South Atlantic run into Central America. If North and South America were not connected by this relatively thin strip of land, the current would continue to flow westward and none of the warmer waters would reach Europe. Scotland, Ireland, England, Wales, and the Scandinavian countries would have climates more closely resembling Greenland's. When you look at a world map, you will notice that England, for instance, is at a latitude north of Newfoundland. Logically, it should be a lot colder there than it is, but thanks to the Gulf Stream, England has a climate more like that of New York City than northern Canada. Indeed, mainland Europe is warmer than North America because the Gulf Stream brings warmer weather with it.
Where is the best place to hide from a tornado if I'm outdoors?
If there is no other shelter around, storm experts usually recommend that you find a trench or ditch if a tornado is approaching and you don't have time to get to a tornado shelter or basement. It is not a good idea to hide under a freeway overpass, as debris can still easily blow inside and prove deadly. Some people believe that you are safer if you are in a mountain valley, because the mountains will block tornadoes. Actually, tornadoes have swept through valleys, and they have even touched on mountain peaks. Tornadoes have been recorded in the Teton Wilderness area at elevations of more than 10,000 feet, 3,000 meters. And during the super tornado outbreak of 1974, many tornadoes struck high areas of the Appalachians. There is also a myth that standing near a river is a safe place to be during a tornado warning. Again, there have been a number of incidents during which tornadoes have been spotted near, or even crossing, streams and rivers as big as the Mississippi and Missouri. It is not unheard of to learn of boats that have been sunk while sailing down a river when a tornado struck.
Who initially proposed the idea of moving continents?
The idea of the continents moving around our planet was mentioned as early as 1587 by the Flemish mapmaker. With German origins, Abraham Ortelius, 1527 to 1598, in his work Thesaurus Geographicus. In 1620, Francis Bacon, 1561 to 1626, also mentioned the idea, noting the fit of the coastlines on both sides of the Atlantic Ocean. By the 1880s, many other scientists were mentioning the connection. For example, in 1885, Australian geologist Edward Seuss, 1831 to 1914, proposed that the southern continents had once been a huge land mass that he called Gondwanaland. But it was German scientist Alfred Wegener, 1880 to 1930, who first formally published the idea of continental displacement, or drift, in his 1915 book, The Origins of Continents and Oceans. He believed the continents were once joined together into one supercontinent, a place he named Pangaea, also spelled Pangaea, meaning all land, that was surrounded by a superocean called Panthalassa. He also suggested that the massive continent divided about 200 million years ago, with Laurasia moving to the north and Gondwana, or Gondwanaland, to the south. Wegener based his ideas of continental motion on numerous observations. The continental distribution of fossil ferns called Glossopteres, from studies by Seuss, the discovery of coal in Antarctica by Sir Ernest Henry Shackleton, 1874 to 1922, similar glacial erosion seen in the tropical areas of India, South Africa, and Australia, the apparent fit of the South America and West African continental shorelines. And, although it may only be legend, by watching ice floes drifting on the sea. Although Wegener is now considered the man who started a revolution in geology, His ideas were hotly debated by scientists of his time. Not only was he a meteorologist in a community of geologists, but he could offer no logical mechanism for the movement of the land masses. It wasn't until the 1960s, long after his tragic death in Greenland. He died at the age of 50 while on a rescue mission, that Wegener was vindicated. By then, scientific measurements, observations, and technology had advanced enough to prove that. Indeed, the continents are moving around the planet on giant lithospheric plates. Wegener's theory of continental displacement was replaced by the new field of plate tectonics, which is the basis for modern geology.
Am I getting hit by neutrinos right now?
Every square inch of Earth's surface are being continuously bombarded by neutrinos from space. Billions of neutrinos slice through your body every second. Fortunately, neutrinos are so unlikely to interact with any matter including the atoms and molecules in the human body that the billions upon billions of neutrinos that hit you every second have no discernible effect at all. In fact, the odds that any neutrino striking Earth will interact with any atom in our planet at all is about 1 in a billion. Even when it does happen, the result is merely a tiny flash of harmless light.
Is carbon dioxide the most harmful global warming gas?
No. Actually, water vapor contributes much more to global warming than CO2 or methane do. The problem is that human activities often increase particulates in the air, which provides nuclei for precipitation to form in clouds.
Why is the sky blue?
While this might seem like a simple question to answer, it has puzzled parents of curious children for ages. The answer can be a bit long-winded. The Earth's atmosphere is made up of gases and a scattering of water and solid particles. As light from the sun enters the atmosphere, most of it passes straight through the air. But some of it disperses because of something called Rayleigh scattering. Shorter wavelengths of light waves in sunlight, those on the blue end of the scale, are absorbed by gas molecules and then released at different angles. Because the bluer wavelengths are scattered in this manner, this is the end of the spectrum of light that reaches people's eyes. However, as your eye looks more and more toward the horizon, you are looking through a much thicker layer of air and less blue light reaches your eyes. Which is why the sky appears bluer as you look up, but paler as you look toward the horizon.
How destructive was the blizzard of 1996?
The blizzard of 1996 left a path of destruction from Georgia to Pennsylvania. Almost $600 million in insurance claims were filed and 187 people lost their lives. 2 or more feet of snow covered Washington, D.C., West Virginia, New England, and New York City. In addition, about $700 million in flood damage was reported in Pennsylvania. Altogether, this one storm cost $3 billion.
How were the Van Allen belts discovered?
In 1958, the United States launched its first satellite, Explorer 1, into orbit. Among the scientific instruments aboard Explorer 1 was a radiation detector designed by James Van Allen. 1914 to 2006, a professor of physics at the University of Iowa. It was this detector that first discovered the two belt-shaped regions of the magnetosphere filled with highly charged particles. These regions were subsequently named the Van Allen belts.
Why is the thermosphere so hot?
While the temperature of the thermosphere can exceed 3,600 degrees Fahrenheit 1,982 degrees Celsius, the atmosphere here is so thin that an ordinary thermometer would not register this temperature. A regular thermometer would indicate temperatures below freezing. Instead, special instruments are used to measure the speed of the few particles that are in the thermosphere. And these indicate the extraordinary highs. Atoms and molecules in the thermosphere are excited by radiation from outer space.
What is a meteorologist?
People usually associate meteorologists with television station weathercasters. Most meteorologists, though, work behind the scenes. They can be found working for the National Weather Service, in laboratories, at weather research stations, or working for universities. Meteorologists need a good understanding of physics, chemistry, hydrology, and other disciplines to do their jobs well. The American Meteorological Society defines a meteorologist as someone who can research, observe, explain, and forecast the weather, who understands the principles behind weather phenomena, and who appreciates the effects that the weather has on Earth. Meteorologists obtain a bachelor's degree in science to do their jobs, and many of them have master's degrees or doctorates. There are also a variety of specialties in the field, such as hydrology and climatology. And many meteorologists study mathematics, computer engineering, electrical engineering, and more.
What is a bear's cage?
The region of heavy rain and hail that usually forms on the southern and western side of a mesocyclone. But to the northeast of where a tornado may exist or may be forming, is referred to by storm chasers as the bear's cage. This is the most dangerous part of the storm, as a tornado can be obscured behind a rain shield, striking with little warning. Visibility is low, and damaging hail, strong winds, and flash floods are also a hazard.
What were the major glacial ice ages over time?
Evidence from the geologic record shows that ice ages have occurred relatively few times in Earth's history, with the first known large-scale ice age taking place approximately 2.3 billion years ago. In the last about 670 million years, ice ages have occurred less than 1% of the time. Geologists believe there have been 5 major ice ages over geologic time. The following lists the occurrences: 1.7 to 2.3 billion years ago, Huronian era, Precambrian. 850 million years ago, Cryogenian period, 670 million years ago, Proterozoic era, Precambrian. 420 million years ago, Paleozoic era, between the Ordovician and Silurian periods. 290 million years ago, Paleozoic era, between late Carboniferous and early Permian periods, 1 million years ago, Cenozoic era, Quaternary period, Pleistocene epoch.